Here's a question that I found on the internet. What is the value of cosecant 45 degrees? So one of the first questions you have to ask you is, what is cosecant? Okay, so what is this cosecant? It's actually the reciprocal of sine any given angle theta. Okay? So cosecant theta equals this. Okay, so to answer this question, we basically have to know what sine of 45 degrees is. Now, one of the useful tools in working out what a sine is to have the unit circle. Unit circle is a circle with a radius r equals 1, hence the unit. A unit square is a square on one side. But anyway, that's not too important about the unit square. Mostly we concern ourselves with the unit circle. Okay? So, where does this lead us? Well, it's pretty handy, pretty useful in working out where the how the angle relates to a triangle. So in the unit circle, we always start here and go across to the right, and that is our 0 point. But we draw around here, so an arc. So at this point is 90 degrees. This point is 180 degrees. So this point here, 45 degrees. Here, this. And the neat thing that relates it to triangles is we can take a triangle from here to here, and we draw this triangle here. We know this length is 1. We know this length is A and B. Right, let's take that out the circle. Our angle here, 45, our B here, and our A here, and R equals 1. Okay, so knowing Pythagoras Theorem, we need a quick reminder. Pythagoras Theorem is A squared plus B squared equals R squared. Now, the neat part about using the unit circle is R equals 1. So R squared is just 1. That makes everything nice and easy. 1. Okay? We also know from here that the length of A is the length of B, because it's right angle triangle here, 45 degrees here. So A squared actually equals B squared equals 1. You want to see how? Let's take the Pythagoras triangle. You know this is 1. You know that's A and B. This is B squared, A squared, and this is 1 squared. These are squared now. So this plus this is equal to 1. Okay, the next bit, how does sine come into this? How is sine going to fit into this? Well, in a given triangle, same triangle, cosine theta is always B. B equals cosine theta. So A, B equals sine theta. Okay? Using this one, B here is actually B squared theta. This equals cos squared theta. So we can swap these around into the trigonometric values. Still got 45 theta. So that looks a bit messy. So let's swap A, B equals 1 for our more specific trigonometric identities. values rather, equals 1. But both sides are the same. Using a bit of guesswork, you can now work out they're both half. Remembering that that's r squared equals 1. So, 1 squared equals 1/2 plus 1/2. Let's square root both sides. So pretty much works out to be 1 over square root of 2, 1 over square root of 2 equals 1. And remember, this one here, just give you a moment. I'll highlight it in white. This is our sine squared, so you could follow through with these white ones. 1 in white is a sine squared. Here. Okay. So therefore we can take that out. We know that sine 45 degrees equals 1 over square root of 2. But we want cosec 45 degrees, which equals 1 over which equals square root of 2. There, our answer, the reciprocal sine squared using Pythagoras as an example of this good mental image. Don't worry, you can draw all of these things. We've learned the trigonometric identity right here, which is really useful for knowing. As you go into upper trigonometry, that will become really helpful. The diagram here is also aid. When I used to do exams, I used to always use this circle. You've got 0, pi over 2 equals 90, pi 3 pi over 2, sine theta, cosine theta. But I'll come to that in another video. Thank you very much for listening.